Hi, have you ever played 2048? Do you know the mathematical concept behind it? Today I will try to introduce it to you by telling a story. Legend has it that the king Yadava once won a big battle defending his kingdom. Unfortunately, the strategy he created in order to win resulted in the death of his son. Everyone tried to make the king feel better, but no one succeeded. One day, a Hindu priest called ocse-pisa came to the palace. In order to cheer the king up, the priest taught him a game of his own invention. It was called chess. At first, the king was a little unsure, but after he played it many times, he understood what the game of chess really was. The king was finally happy again, and he asked Sessa what he wanted as a reward: money, a palace, a city. He could name his prize. The Hindu priest refused them all, but the king insisted for days. Eventually, after looking at the chessboard, ocse-pisa said, "You will give me a grain of rice for the first square, 2 for the second, 4 for the third, 8 for the fourth," and so on. The king laughed at the request, replying that he could have anything in the world but a few grains of rice were enough for him. In your opinion, will this kilo of rice be enough to cover the chessboard following Sessa's request? Let's work that out. On the first square, we place 1 grain of rice. On the second, we place double what we placed on the first. On the third, double what is on the second. On the fourth, double the third, and so on. Notice that the number 2 is multiplied by itself 3 times here. We can now introduce the exponential notation. On the fourth square, we have 1 times 2 times 2 times 2 grains. This is equal to 2 to the power of 3 grains. In the same way, the third square will have 2 to the power of 2 grains. The second square, 2 to the power of 1. And in the first square, we find the definition that 1 is equal to 2 to the power of 0. At this point, we can easily understand how many grains of rice we will have in the 64th square. 2 to the power of 63. With the help of a calculator, we are able to approximate this value to be 9 billion. What we are really looking for, however, is the total number of grains on the whole chessboard. We can find this in the following way. On the first square, there is 1 grain, so we have 1 grain in total. On the second square, there are 2 grains, so we have 3 grains in total. When we arrive at the third square, we'll have a total of 7 grains, and the 8 grains on the fourth square brings the total to 15. Notice that 15 is equal to 16 minus 1. In other words, it's equal to 2 to the power of 4 minus 1. The same is true of the grains on the first 3 squares. 7 is equal to 2 cubed minus 1. On the first 2 squares, 3 is equal to 2 squared minus 1. And the single grain on the first square is equal to 2 to the power of 1 minus 1. Hence, we come to the conclusion that after all 64 squares are filled, the total number of grains will be 2 to the power of 64 minus 1. That is approximately 18 billion grains. This is of course a large number, but how large? Let's try to comprehend it. Here I've counted 400 grains. Let's see how heavy that is. It's 10 grams. We can now write the equation. 400 grains are equal to 10 grams. So 40,000 grains are equal to 1 kilo. So how much does 18 billion grains weight? 461 billion tons. But what does that mean? Consider this. During one of the most successful years for the production of rice in China, it produced 167 million tons of rice. How many years would it take to produce our 461 billion tons of rice? Let's make some quick calculations. It would take 2,752 years for China to produce it. The day after Sessa made his request, the court's mathematicians went to the king and told him that collecting all the rice he requested would take more than 2,000 years. Lord Sessa wanted to teach the king how an apparently simple request could have a huge value. However, once the king understood this, Sessa gave up his request and became the governor of one of the kingdom's regions.